Today we're going to learn about slope. This is an introductory lesson about main characteristics of slope, different types of slope, and important vocabulary that you must know in order to be sufficient in slope questions and, of course, in the future, Algebra 1 and Algebra 2. So what is slope? Slope is describing the steepness of the line. So yes, we are going to be doing a lot of graphing and analyzing of the graphs, and we're going to be using slope to describe our graphs. So yes, you are going to see variety of graphs. They will be behaving in different ways. They're all going to be very linear, so that's going to be a major requirement when you are graphing, to make sure you have a straight line. So we're going to talk about, why this value is the biggest slope in the near future. But the steeper the line, the sharper it is rising, it is going to be creating the biggest slope. So let's discover a little bit more. We use a special variable m, to represent slope. And the interesting fact that it has to do with the French word monter, which means to climb or to rise. And that's what our lines are doing. They're climbing, they're rising. So this is a really interesting and fun fact. So there are 4 types of slopes. And I'm going to go ahead and highlight this. And of course, anytime you work in your notes, you are welcome to add any additional information, any additional highlighting as you might see fit. So our first type of slope right here is called positive. Why specifically it is a positive slope? Because, and yes, we are going to use a plus, because our line, our graph is rising when we look at it from left to right. A little bit of a reminder, since in English language we read from left to right, we observe the movement, the change from left to right. It is rising, so it's going to be positive. So on the same token, you can see, then this one seemed to be falling, and we would call this a negative slope. So it does have to do with negative values. We're going to see those firsthand pretty soon. Our horizontal line is representing 0 slope. Okay, 0 as a number 0. Okay, it has to do with no rising. It does not rise, 0 rising. So that's where that value is coming from in the name. And then we have what we call this right here is undefined. This particular slope, so all of these will have a numerical value, but this particular slope will always stay in this term undefined. So we never have a numerical value that we can give to this particular graph. A lot of times you might want to relate to the slope dude. And this is just a quick device that you might find helpful when you try to remember which slope is which. So here's our slope dude. This is a positive slope, and I have a plus. This is a negative slope, and I have a minus. Okay. He has undefined nose. Okay, slope, undefined slope. This is a U, undefined. And so with a 0 slope, 0, 0 as his mouth. So it's just handy. If you find it helpful, you can always sketch it in your paper as you starting to analyze these slope graphs. We are going to spend a lot of time with our graphs. We're going to be creating graphs and analyzing them. So just a couple of important steps for our analysis. We always have to identify the type of slope. Okay, that should be the first analysis that you really spend time on, because the type of slope will help you to eliminate wrong answers and choose correct answer. Okay, so we're going to be really paying attention to that analysis and try to make sure that we can eliminate incorrect answer choices. When we are going to work with our graphs, a lot of times we're going to be working with actual numerical values and data, so it's not going to be just a random set of lines. So for our analysis, for our slopes, positive or negative slopes, we're always going to be choosing or marking two perfectly positioned, I'm not spelling it correctly. All right, I had to change it to perfect points, not perfectly positioned. But these two perfect points, what in the world are those? So when we look at our examples of these three graphs that you are seeing in front of you, you are seeing just lines. No points have been plotted on those lines. So we sometimes have to make sure to plot our own points to analyze. What does it mean, perfect points? Perfect points are points that you can 100% with confidence tell what are their coordinates. It's going to be very important for our process of analyzing. So in example number 1, I'm going to make this a little bit more bold, but we have a proportional graph. It goes through the origin, and so then we have our particular point. You know, we could say this is our 0, 0. This is our good point. Then we can click on, not click on, but select this particular point. I'm going to zoom in just a little bit. And just to kind of show you why in the world did I pick this point. Again, origin is very obvious, but I don't want for you to pick point that's right here. And that's specifically because I don't really know what the value of that point is. I know it's sitting on the graph, but when we are selecting our coordinate point, that's perfect coordinate for us to choose from. I'm going to just make this really, really bold. We have to make sure it is perfectly positioned on your line, and it has perfect coordinates. All right, let's take a look at this example. Of course, your origin right here, and looks like this particular graph right here. So it's origin, and then if I were to find the coordinates, is it perfectly positioned? Yes, it is. So I can say this is 3 and 1, 2, 3, 4 and 4. And so again, other questions might not be as, or other values might not be as clearly defined. Again, I would not want to select this point right here. Okay, yes, it is on the graph, but there's no telling what is the value. So we should not have anything that says 2.4, negative 3.1, coordinates like that. Before we move on to your last example, just to make sure that we're practicing our types of slope, this particular graph is falling from left to right. Again, how can I tell? when I am moving my line, it is falling from left to right. It's not rising, it's actually falling. So that is going to be my negative slope. Okay. And in this example number 2, we have opposite situation from left to right. When I move my pen, I see that my graph is rising. It's going up. All of my values are increasing. So this is my positive slope. And again, I'm referring back to our notes. Our last example right here is undefined slope. It is a vertical line, and we have a case of undefined slope. So make sure you're using your notes as you're practicing with these questions today. I'm going to pause the video here, and please click on video number 2 to work with the flip side of this note.